Welcome, my dear learners, to today's interesting episode on this very channel. Remember, we are still on the real number system and we are on standard form. Today's lesson is just a summary of all what we have done in this very session. I mean, standard forms. Remember that we've been able to talk about multiplication of standard form and then division of standard forms. We have also been able to talk about expressing numbers in standard forms and then vice versa. We talk about the addition and then subtraction of standard form. So we are going to combine all of these in one question and then we see how best we can do that. So we have a question on the board which consists of the multiplication of standard forms and then division of standard forms. So we are going to combine all these concepts that we have learned in solving these two questions. So the question says, without using calculator, we have to evaluate this and then that. So let's see how it goes. So we have our solution. So we have our first question which says, so we have our first example. Now we have to simplify this without using calculator. So what we are going to do is that we are going to express the decimal fractions as a whole number. And then we can do that through the standard forms. So we have learned how to express these numbers in a whole number. So we are going to get, now we know that the decimal points is at this well point. So when we move it to the right, it is times what? 10 raised to the power negative 1. So we are going to get 6 times 10 raised to the power negative 1. And then we have our 32. And then we are also going to express this in a whole number, and we can do that using the standard form. So the decimal point is here. We are going to move it so that it will be behind the 4. And we know that each movement to the right is times what? Times 10 raised to the power negative 1. We moved 3 times, so times 10 raised to the power negative 3. We've already done this in our previous session. So we're also going to convert this to a whole number. We have 10 raised to the power negative 1. We convert this also to a whole number using all the standard forms. So we have 8 times 10 raised to the power 1, 2, 3. So negative 3. Then we have times. We are also going to convert this also to a whole number. So we have 16 times 10 raised to the power 1, 2, negative 2. So the next thing that we are going to do is that we are going to group the whole numbers together, and then those with the power of 10 we group also them together. So we have 6 times 32 times what? 4. Then we have times 10 raised to the power negative 1 times 10 raised to the power negative 3. Then we have 12. We also group the whole numbers together. Times 8 times what? 16 times 10 raised to the power negative 1 times 10 raised to the power negative 3 times 10 raised to the power negative 2. So since all of these numbers are multiplied, we can cancel them out. Or you can decide to multiply them and then simplify. But remember, we have to do that using the calculator, without using the calculator. So we can cancel them since they are all multiplying. Now we know that 6 will go into 12 too. You also know that 4 will go into itself 1, and then into 16 we have 4. We also have this into 32 we have also 4. Good. You know 4 is also here. 4 can cancel 4. We are left with 1 times 1, 1. And then we have 2 times what? 1. That gives us what? 2. Good. So we have times 10. Let me write it so that you can see it well. So we have 1 times 10 raised to the power negative 1 times 10 raised to the power negative 3 all over 2 times 10 raised to the power negative 1 times 10 raised to the power negative 3 times 10 raised to the power negative 2. Good. So at this very point, you can apply our basic knowledge in indices. You know that in indices, when two numbers are multiplying, they have the same base 10 and 10. What do? We pick one of the base, we add their exponent. So we are going to have, in indices, we are going to apply our basic knowledge in indices. So in indices, when two numbers are multiplying, they have the same base 10 and 10. What do? We pick one of the base, we add their exponent. So we have 10, negative 1 plus negative 3 give us negative 4. All over we have our 2 times the same application of indices law. When two or more numbers are multiplying, they have the same base. We pick one of the base and then we do what? We add their exponent. So this is giving us what? Minus 6. Good. So we have, let's continue from here. 1 over 2, we know that is the same as what? 0.5 times 10. You know that in indices, when two numbers are dividing, they have the same base. What do? We pick one of the base, we subtract their exponent. So we are going to have minus 4 minus another minus what? 6. Good. So let's continue from here. So we have 0.5 times 10 raised to the power positive 2. But remember, the question is given in a standard form, so we have to leave it in a correct standard form. So in doing so, we are going to get 5 times 10 raised to the power negative 1 times 10 raised to the power positive 2. So when you simplify, you are going to get 5.0 or 5 times 10 raised to the power 1, which is the same as what? 10. And that is that as easy as A, B, C, and then D. Let's take the second example and then see how it goes. So we have a second example. We have to simplify this without using the calculator. Good. So in doing so, we know that we have the root of these numbers. Okay. And we know that the root sign is the same as what? Power of what? Half in indices. So if you have root of 2 is the same as what? 2 raised to the power half. I believe you remember that. Good. So we are going to apply the same concept in this question. So the root sign can be written as what? As a power of half. So let's turn it. And then let's bring the power of what? Half. Good. And that has become very simple. Good. So applying the same concepts like the previous example that we did, we are going to express these numbers, decimal numbers, in a whole number, and then this also decimal number as a whole number through the application of what? The standard forms. So we know that we can write this as 48 times 10. How many movements? 1, 2, 3, 4. So times 10 raised to the power negative 4. Then we have 81 times 10. How many movements? 1, 2, negative 2. And then we have times 10 raised to the power negative 7. All over. We also convert or express this as a whole number through the use of the standard form. So we have 27 times 10. How many movements? 1, 2, 3. So negative 3. Then we have times 4. How many movements? We have 2 movements. Times 10 raised to the power 6. Remember, all this is raised to the power of what? Half. So after that, you group those whole numbers together, and those with the power of 10, you group them also together. So we have 48 times what? 81. Is that all? Okay. Then we have 10 raised to the power negative 4 times 10 raised to the power negative 2 times 10 raised to the power negative 7. Good. Then also group those. We also group the whole numbers together. We have 27 times what? 4. Then we have times 10 raised to the power negative 3 times 10 raised to the power what? Negative 2 times 10 raised to the power what? 6. Remember, all of this raised to the power of what? Half. Since we are multiplying, we can cancel them out. I mean the whole numbers, we are going to cancel them out so that it will be very easier for us to do the working, because we have to do that without using the calculator. So we know that 12 into 48 will give us what? 4 into 40 will give us 12. 27 into 81 will give us what? 3. Is that all? Good. So we have 12 times 3 will give us 36. And then we can apply our basic knowledge in indices. When two or more numbers, they are multiplying, they have the same base, 10, 10, 10. We pick one of the base, and then we add their exponents. So we have this plus this will give us minus 6, plus this will give us what? Minus 13. Then all over, we are left with 1 times what? Indices. Applying the same concept in indices, we have minus 5 plus 6 will give us what? 1. Good. Remember, all this is raised to the power of half. Let's continue from here. Now we have 36. Now remember that we also have 10 raised to the power negative 13 dividing 10 raised to the power of 1. Applying the same indices division law, when two numbers are divided, they have the same base, we pick one of the base, we subtract their exponents. So we have times 10 raised to the power negative 13 minus what? 1. Good. All raised to the power half. Let's continue from here. We have 36 times 10 raised to the power 10 negative 13 minus 1 will give us what? Negative what? 14. Good. Now remember, we are still having a power of what? Half. Now remember that we said that the half is the same as what? The root sign. So we can bring our root sign back, okay, if you want to. Let's continue from here. 36 times 10 raised to the power negative 14 all raised to the power half. So I said that the root sign, the half, is the same as what? The root sign. So you can write it as root of what? 36 times 10 raised to the power negative what? 14. Good. And we know that this is the same as when you have, let's say, root of a times b is the same as root of a times what? Root of what? B. Good. So we can split this into this very form. So we have root of 36 times root of what? 10 raised to the power negative 14. Root of 36 will give us what? It will give us 6, right? Good. Now we said that the root sign is the same as what? Power of half. So we know that this is the same as negative 14 raised to the power of what? Half. So we have 6 times, so this is the same as negative 14 times 1 over 2. So this will cancel this. We are left with what? negative 7. So we have 10 raised to the power negative 7. 10 raised to the power negative 7. And that is that. As easy as A, B, C, D. I'll give you one question. You can pause the video, you write them down, and then you try your hands on it. It is just one question, so write it down, you try your hands on it. So this is your try question. Pause the video, you try your hands on it. See you tomorrow. Bye bye.